Scott's going to be talking to us about tips and tricks in SQL Enterprise Geodatabases. Scott specializes in web-based GIS application development and is experienced in a variety of GIS platforms and programming languages. He focuses on creating custom, user-friendly, interactive web-based GIS applications that provide access to detailed spatial data for a variety of users. He enjoys photography, science fiction, traveling, and the occasional homebrew. I'll turn it over to you, Scott. Thank you.
Thank you, Ryan. Appreciate that intro. We are going to cover a whole bunch of really technical stuff in the next 30 minutes or so. I had one person say, "Are you sure you can get all this in?" And I don't know if I can. We'll get there, and certainly open to questions. You can stop by our booth after the session, and I'll be there, and we can get into more detail if you like. So let's jump right into this. One of the first things I wanted to show you was let's talk about a versioned feature class in a SQL database. And again, I should probably precursor everything by saying most everything we're talking about is using SQL Server Management Studio, where you have access to the table design and views and all of the things inside a SQL Server. So one of the first things wanted to show you here is in a version feature class, you basically have three things that you need to think about or be concerned with if you're going to reorganize fields. You just go in and design the default table, the feature class table, the adds table, and the deletes. Well, and showing you that the deletes table, there's nothing there to worry about. So if you wanted to say, take a field, I'm going to get my laser pointer here. If you wanted to reorder things, you could just simply move them around, make sure that the order of them are the same. And there's nothing to worry about in the deletes table. Save those changes. And then in the view, there's going to be a view of this feature class. Usually ends with a VW or a EVW extension. We're looking at, in this case, it's a water pipe feature class. There's a deletes table of D143 and an adds table of A143. And again, so this is how when you add this feature class to ArcGIS, either ArcMap or ArcGIS Pro, it's actually reading this view. It's joining all the records from the feature class and removing the records from the deletes table, adding the records from the adds table. So that's what you see in ArcGIS. And you can simply reorder these fields just like you would in the table design, make them the same order. And once you do that, when you refresh that layer in ArcGIS, you will see those changes. And I talked a little bit beyond that. So again, this is the feature class part of it, and then the adds and deletes part of that. In the column registry table, there is, here we're looking at all of the fields for a particular, well, not necessarily the same feature class, but it's all the columns. And there's an online resource here that you can go to, which, let's see if I can go there real quick. We'll see what happens. This is on Esri's website. You probably can't see that now, can you? Sorry about that. I was sharing PowerPoint instead of my screen. So come see me at the booth and I'll show you where that is. But it points out the different types of fields and what these types mean. These are referencing a specific field type, be it integer, long integer, short integer, text, or whatever, what have you. This is basically a summary of the table from Esri, what those fields mean. So a couple extra here. I'll point out that you've got ID 1 or field type 1 is a short integer, 2 is a long integer, some of the more common ones. And I guess here's a link to that, where that goes to. The double and text, those are the most common ones you'll see in the column registry. So you can change field types by editing the column registry, but you do need to keep in mind some limitations. You can go from a short integer to a long integer, from short to long, or long to double, or even short to double, as long as you're going up in the hierarchy of field types. And pretty much anything you can change to a text field, and you can increase the length by changing those values in the column registry. And then you don't forget that you have to make the same changes in the feature class table and the adds tables. And then as far as the views go, you just have to go in and open the view and edit, basically open the view and save it, so that the updates to those column types is recognized by the database. The other thing I've been using a lot in SQL, and it can come in very handy, is triggers. A trigger is something that you program in what happens when something changes on the table. And this is on, say, in this case, a trees feature class. And after insert, what's going to happen? We're going to look at, we're creating a variable called max tree ID, and we're setting that ID to selecting the max ID from a field. And if it's null, we're making it 0. That's what the variable is set to. We're selecting the maximum ID from the trees. And this tree ID is an integer field. So because on a feature class, you can't change things like have it be auto numbered, those types of things on a field that you create, have it be incremented. So this is a trigger that increments it after that record has been inserted. So we're grabbing the ID and we're adding 1 to it, and that's what it's doing. It's setting that value for you in the trigger. And there's a ton more you can do with triggers, just looking at the data being the record coming in. Also, take a look at views and how you can concatenate values. So often I see a field where maybe it's address or owner name, where a whole bunch of things are all put together and they're calculated that way, and that exists in the feature class table. Well, anytime one of those fields would change, you would then have to run a calculation, maybe an ArcMap, to recalculate the field that brought all those values together. If you create a view, you simply can do that concatenation in a view, and you get all of this information into one field that way. So definitely look at using views for creating that data. So here's another example of addresses, where I've got a house number field, a unit number field, and the street name. And I created a view that creates a field called address. And that basically concatenates those 3 values into one field that ArcGIS will see when you load that view into ArcMap. We'll show how that works a little bit further along here. So anytime one of those fields changes, the address field is automatically updated. There is no post-processing of data. It's automatic because it's a view of the data. Here's another thought, taking a look at using dates and calculating the age of something. So I have a field called date installed, and this has time and everything in it too, but it's really just the date. So when I take the current year, the year of now, and I subtract the year of the date installed value to create a field, virtual field called years installed, I get an actual date. So this was actually created in 2020, the snapshot here. So I have a value of 8 here for something that was done in 2012. At the turn of the year, January 1st, this would automatically become 9. So you can use calculations like that in your views as well to come up with dynamic data. Also, since we're in a spatial database, a geodatabase with spatial functionality, you can grab instead of, like I've seen, in ArcMap, you can calculate the X of something or the Y of something of a point if you're wanting to expose the coordinates of something. Instead, a view can do the same thing. So if I have a view that is grabbing the shape, the shape field, grabbing the spatial X and the spatial Y of that shape field from a point feature, you can get the X and Y of a feature class. This is a point feature, so the valve number is what I was showing here too. So because it's a spatial database, you can perform geometry functions on that geometry field, being the shape field is a geometry field. Aliases. When you're doing things in views, it really helps to be able to read the code when you are aliasing the tables. And so, for example, you can go from a real complex looking, crazy view definition of a select command, and you see owner parcels duplicated in here and parcel history duplicated in here. So there's a couple of tables being used here. But if you alias those tables, you can take that really massive string of select statement, and I just aliased F as the parcels being the feature class and H as the history. And so now you've got a much more readable view. And you can see where I've got the feature class F and H here. Worth taking a look at. Scalar functions. So a scalar function is a function that you call in a view. So here I've got a scalar function called sand structure inverts, and all I'm doing is passing my structure number to that function, and that function grabs the inverts from the pipes where the pipes have the structure number in it. So I'm building a string of inverts for this sanitary structure from the inverts that are stored on the pipe. And this is what that looks like when that field is used as a label. So I've got a view of the sanitary structures with a field that calls that scalar function, getting the inverts and other pipe data from the pipes where that pipe indicates that its upstream or downstream structure is this particular structure, SA006 in this example. So there's lots of really interesting things you can do with the relational database by using some scalar functions, among other things. Or how about returning records based on a geographic location? And again, I'm going to show you some things that I'm doing in ASP.NET with web-based forms for getting other information related to the feature I'm looking at. So here's an example of a hydrant where I've picked this hydrant and just showing you the actual distances to hydrants nearby. I've done these measurement tools. So the closest one is 229.56 feet away. And in my web-based form, when I'm doing a hydrant flow test, one of the things you want to do, or often do in a hydrant flow test, is select the flow hydrant. So this is a hydrant that I selected on in that first image. This is hydrant 978. I can kind of see it here. When I'm doing a flow test on that hydrant, I'm grabbing all of the hydrants nearby, and I'm showing in this drop-down list through a stored procedure the hydrants that are close to this hydrant that I'm acting on. So again, a database function that I can use in this form. Instead of listing every single hydrant, really whenever you're doing a flow test, you're only going to make one of the nearby hydrants the flow hydrant. So this shortens that list extensively. So again, a stored procedure to call up nearby hydrants based on the location, again, using that geometry value. Edit values in the base table. So you have a feature class. Instead of going into ArcMap and using the calculate thing and having to turn on editing, if you're in the database, you know exactly what you need to do. You can just open up that table and edit those values directly. When you're doing editing in the results pane, you can't include the geometry field, the shape field. Otherwise, your update won't work. So all you have to do is just remove that view or that field from your results view, and you can edit away. And in many ways, you can do that with doing some global things, where in this case, I'm changing Wisconsin Avenue, East Wisconsin, making sure everything is the same. Changing Avenue to Ave just by abbreviating it, or I'm sorry, changing it to Avenue where it was abbreviated Ave. And so every instance of that will change all at the same time. Really easy to do that in the database. Including using views in a map. So you want to ensure that when you do a view, you create a view, the shape field has to be in the view. And this is what it looks like in ArcMap when you add a view. You're going to see this to change to a change query instead of change source. And in that, and I'm hiding some things so you're not seeing exactly where this is coming from, but what you're going to get is essentially what looks like a query. And so this was parcel history geo, which is the view that I created. So you can see the fields that are included in that view, where we talked about address was one of those calculated values where I'm concatenating a number of fields together. Owner name search was another field that is calculated by joining all of the owner fields together so that I have something to view or see. When you're using a view or displaying a view in ArcMap, make sure that you use the key value that is unique, especially if you're in a case where you have a one-to-many relationship, where you're joining a table that ends up duplicating the feature class. You can't use or should not use the object ID as your key value because it's no longer unique in a one-to-many relationship. You want to have a unique key value in your related table. That becomes your unique ID. So in this case, I'm showing here GUID is the unique ID from the related table, and global ID is the feature class ID. This global ID is going to be duplicated and will no longer be unique in the view. So you want to make sure that you're pointing to the field from the related table that will be unique. In the GDB items table, it's XML definitions of all kinds of things, feature data sets, feature class definitions, and domains. Specifically, I want to talk a little bit about domains because changing a domain is one of the things that's most challenging, or I would say kind of cumbersome, not very fun, can't change the order, can't really add things. It's so cumbersome. With a script like this, where you place the XML code here, and you're updating a domain by the name, you put that name in here. So here's an example of what a coded values XML domain looks like, and this one's simply north is the name, N is the code, and so on. The name of this domain is direction. If I paste this code into this portion of this script, and by name put in direction in that direction in the name here, and I run this script on the database that it's in, I can update my domain in a matter of seconds. And if I wanted to either add to this list or change this list or put a different order or put other as a new value on the bottom, I just copy this code and add that in there, and I've got a new domain value. Run your script and your domain is instantly updated. One of the best discoveries that I've made in recent years for modifying domains is having this be a tool to use. Real quick tip on our catalog, really not necessarily related to SQL, but your catalog data is stored in app roaming Esri, and then the version you have inside our catalog. You'll see that there are files in there, files that are AGS for connections to ArcGIS Server, and .ste that are enterprise geodatabase connections. These do not have to live in the user's folder. These could be anywhere on your network. So if you have connections that you've created, you could store these on your network and just create a folder connection to that folder on your network, and others can use the same connections. So that's just something that we've done here at GRAEF, that you don't have a whole bunch of definitions that are created on your desktop, and when you get your computer replaced, they're gone. So if you're storing them on your network, they will always be there for you. And that brings me to the end. Let me pull up any chat and see if you've got any questions. Where did that go? Let's see.
I can read the first question to you if you would like, Scott.
Yeah, go ahead. Go ahead.
When domains are changed, how do you manage the symbols on the map that are symbolized domain specific?
Well, that's an important thing. When you do make a change, you want to be sure that you are updating. If you're changing an existing domain value that is already populated in the feature class, you go in and you edit your feature class in. I edit the table in SQL and replace all instances of the old value with the new value. So you want to do that for one thing. I think that answers that question, yeah.
We have a couple more minutes for any questions, if there are any. Go ahead and enter them in the chat, and I'll read them out to you. All right. Thank you very much, Scott.
All right. Thank you.